There are two major branches of statistics: qualitative and quantitative. In the first, these would be qualitative words or descriptions. In contrast, quantitative data are numbers. To help keep them straight, for qualitative, think L for literature. Let's try some, classifying as qualitative or quantitative. The weights of members of the football team. These are numbers, specifically numbers that you can add and subtract, and it makes some sense. Quantitative. The flavors of Ben and Jerry's ice cream. Little chunky monkey, anyone? Qualitative. The jersey numbers of the women's basketball team. Yes, they're numbers, but let me highlight that when we're talking about quantitative, we should be able to add and subtract these. And that doesn't really make a lot of sense here. So this is qualitative. Student ID numbers. Same idea. Numbers, but you can't add and subtract them. This too is qualitative. In this whole qualitative versus quantitative battle, within quantitative we have two other branches. The first are called discrete measurements. These are things that you count. The second, for instance, I have 5 beautiful daughters, 2 pennies and 4 dimes in my pocket. 3 mean thoughts for the day, is called continuous. These are things that you measure. I use a thermometer to measure the temperature. Today, it's about 52 degrees. If I measure myself, I would say I am 5 foot 10 inches tall. But I've always wanted to be blonde. Or we could measure your age on a timeline. My age? Well, it's over here somewhere. You try some. Classify these as discrete or continuous. The temperature in Fahrenheit of cities in North Mississippi. Do you count the temperature or do you measure the temperature? You measure it with a thermometer, it's continuous. The number of rooms in a house. Do you count them or measure them? Counting the number of rooms makes it discrete. The number of peanuts in a jar. Do you count them or measure them? The number is counted. It's discrete. The height of a door in inches. Do you count it or measure it? Heights are measured. This one is continuous. There are also levels of measurement that determine which statistical test should be run, but that comes later. The levels of measurement are, in order, the first and lowest level is called nominal. If you know any Latin, most of us don't, the prefix nom would mean name. Examples of this would be things like race, religion, political party, or even your favorite sport. In all of these instances, they're names, they're categories, but there's no order. Our next category is called ordinal. Ordinal level measurements have, as the prefix here also indicates, order. A prime example of this would be the infamous Likert scale. We've probably all seen this before. This is a Likert scale. There's order, and you have to choose which one represents you, but there's no number to it. Our next level is called interval. Interval level measurements are numbers. Numbers specifically that you can add or subtract, and it makes some sense. Things that would fall into this category would be test scores, temperatures. The last level of measurement is called ratio. Ratio level of measurements you can make a ratio out of by dividing or saying something is 2 times as big or as old. These are generally things that are measured, such as height, age, or the amount of money someone makes. There is a natural break between the two, with the first two being considered qualitative and the last two are quantitative. It's time for you to try again. Determine the level of measurement. Today's high temperature in Fahrenheit for varying cities across the U.S. These are numbers, so it's quantitative. You can add and subtract them, so it could be interval, could it be ratio? If it's 0 degrees one day and 2 degrees another, is it twice as hot? No, not ratio. Interval. Colors contained in a box of crayons. Qualitative data. Is there order? Not unless you're pretty particular about how your crayons are. It's nominal.